All right, welcome, brothers, to the floor. As your senior lead engineer, I am super excited to set the stage for how we're going to protect our ultra-pure water system's RO membranes today. Look, if you're out there installing and operating UPW systems, you already know that keeping those membranes pristine is literally our top priority. So today's explainer is basically a complete masterclass on antiscalant dosing pulled straight from our field manuals. Let's get right into it.
Here's a quick look at our troubleshooting walkthrough. We're going to cover 1. The antiscalant defense system, 2. Costly operating mistakes, 3. Step-by-step dosing adjustments, 4. Monitoring and fine-tuning, and 5. Safety and key takeaways.
Starting off with Section 1, the antiscalant defense system, our system overview. Let me tell you, controlling inorganic mineral scale is an absolute life or death matter for the lifespan of our membranes.
Okay, picture the physical skid out on the floor for a second. The injection coil is placed directly between the 5-micron cartridge filter and the high-pressure pump. Now, why right there? Well, injecting at this exact spot ensures perfect mixing into the RO feed stream without totally clogging up our clean white cartridge filters. Think about it. If we dose too early, the filter just traps the chemical. But if we dose too late, it simply doesn't mix properly before hitting the pressure vessels. We need that sweet spot.
So how exactly does this chemical work its magic? Imagine these blue polymer chains actively attacking chalky calcium carbonate crystals 24/7 to defend our membranes. It happens in 3 ways. First up, threshold inhibition. This basically stops nucleation in its tracks, delaying precipitation even when the water is supersaturated. Second is crystal modification. It actually deforms the structure of the crystals as they form so they can't grow and lock onto our clean membrane surfaces. And third, dispersion. This keeps those tiny little particles suspended in the concentrate stream so they just get flushed right out of the whole system.
Moving to Section 2, costly operating mistakes. Let's talk about how to avoid those really expensive errors that can cause permanent equipment damage.
Brothers, listen up and pay close attention to this number, 75%. When our RO recovery rate hits this percentage or higher, the concentrate stream thickens up immensely. All those mineral ions, calcium, sulfate, silica, they get highly concentrated, and the risk of catastrophic scaling absolutely skyrockets. Basically, the higher the recovery, the faster the scale builds up if our antiscalant isn't dialed in perfectly.
Now, I want to rapidly run through these common field mistakes because honestly, I see them way too often. Underdosing to save a few bucks, that means scale forms silently and it's going to destroy your membrane over a few months instead of it lasting for years. Overdosing is honestly just as bad. Throwing too much antiscalant at the system can actually breed biofouling or organic fouling. Another huge mistake, trying to treat the scale after it forms. Remember, antiscalant is preventative. If the scale is already there, you need a CIP, a clean-in-place acid wash, not more antiscalant. And finally, skipping your feed water analysis or ignoring your flow meter and pump calibration, well, you're just flying completely blind out there.
So the crucial thing here is properly diagnosing what's actually happening inside your pressure vessels. If you see differential pressure spiking at the end stages, down on the concentrate side, you are very likely dealing with scaling. That's your chalky, inorganic mineral buildup. But if the pressure spikes evenly across the early stages, that's usually organic or biofouling, more of a slimy buildup. Whatever you do, brothers, don't increase your antiscalant if you're dealing with biofouling. You will only make the problem so much worse.
All right, bringing us to Section 3, step-by-step dosing adjustments. This right here is the exact protocol for manually adjusting the diaphragm metering pump on the floor.
We've got 6 exact field steps to follow. Let's walk through them slowly so every brother on the floor has this workflow memorized. Step 1. We prepare our tools, check the tanks, and gear up with our PPE. Step 2. Evaluate the membrane's condition and scaling indices. Step 3. Calculate our current and required dose. Step 4. Carefully adjust the pump stroke length. Step 5. Monitor the flow right after that adjustment. And Step 6. We log our data and hand it over properly to the next shift.
Now, during Step 2, when evaluating the membrane, we are looking for a very specific trigger. If you're looking at your SCADA control screen and you see the differential pressure, the delta P, spike by greater than 10 to 15%, or your normalized permeate flow drops by that same amount compared to your baseline, we are in the danger zone. That right there is your golden signal that scaling or fouling is happening, and it is time to take action.
Okay, Step 3 is the math. Don't worry, it's straightforward. To calculate your exact dose, you just take your pump flow in liters per hour, multiply it by your tank concentration in milligrams per liter, and then divide by your RO feed flow in cubic meters per hour. That gives you your exact dose in parts per million.
Standard dosing is usually right around 2 to 5 ppm. But, if our feed water analysis shows extremely high silica or hardness, we might actually need to push that up to 8 or even 10 ppm.
All right, step 4, the physical adjustment. When you go to grab and turn that stroke length knob on the diaphragm metering pump, you've got to follow these rules. If you need to increase the dose, do it in small 10 to 20% increments. We never, ever double the dose overnight. If you're decreasing it because the water is super soft and the LSI, the glandular saturation index, is deeply negative, do it just as slowly. And this is the most important part. If you hit the max recommended dose and scaling continues, never exceed that limit. At that point, you actually need to lower the RO recovery rate or drop the feed pH. Don't just blindly pump more chemical into it.
Section 4. Monitoring and fine-tuning. Making that physical adjustment is only half the job. We have to verify if our pump tweaks actually stabilize the UPW system. So, after you touch that pump, I need you checking the delta P daily on your shifts. Watch those skated trend lines for recovering normalized permeate flow rates. If it stabilizes, perfect, you hit the sweet spot. Also make sure to recalculate the LSI after 2 to 4 weeks. And physically go out and inspect those 5-micron pre-filters. Imagine pulling out a clogged, brown, gross filter versus a nice, clean white one. A clogged cartridge before the RO skid? That usually means our antiscalant is mixing with incompatible chemicals or impurities right at the injection point. Not good.
And finally, Section 5, Safety and Key Takeaways. We've covered all the technical steps, but I want to bring it right back to what actually matters most, protecting the team.
Safety first, always. Mandatory PPE is completely non-negotiable here. Rubber, chemical-resistant gloves, and safety goggles. If you get concentrated antiscalant on your skin, you drop what you're doing, head straight to the safety shower, and flush it for 15 minutes, no exceptions. And, critically, beware of chemical incompatibility. Never mix antiscalant directly with strong acids, strong oxidizers, or cationic polymers in the dosing tank. We want to completely avoid any dangerous reactions in precipitation right next to our dosing skids.
I want to close out this explainer with a golden rule straight from our manuals. Antiscalant is insurance for the RO membrane, not a cure. It prevents scaling. It absolutely doesn't clean it. So, I'm going to leave you brothers with this final provocative thought as you head out to the factory floor today. Are you just blindly trusting your pump settings, or are you actually listening to what your RO data is telling you? Keep your eyes locked on those pressure gauges, stay safe out there, and I will see you on the next walkthrough.